Apex. And specifically, we're going to be talking about quality within Apex. Today's presentation is called Codify and Enforce Your Organization's Apex Standards. And this is really, really powerful stuff. I'm super excited to share. So thank you, Amit, for the opportunity for me to share this content with the Apex Hours family. Okay. Next slide here, just a little bit of introduction about myself. My name is Mitch Spano. I'm a 16-time certified Salesforce technical architect. I am a senior application engineering manager at Google. I've been in the Salesforce ecosystem for coming up on 10 years in October. You can find me on Twitter at Mitch Spano. That's probably the easiest way to get a hold of me. And you can check out a lot of content that we're going to be sharing today is available on my blog, which is at www.mitchspano.com. Okay, before we get started, just want to give you guys a content warning. This stuff is very, very tailored toward engineers, developers, and technical architects, okay? We are going to be talking about software engineering. We are going to be talking about computer science. Yes, we're going to go over source code. Consider yourself warned. But also, if this is something that might, please don't leave the Zoom call right now or stop watching this video if this is recorded in the past. I'll tell you what, this is something that's going to be empowering for everybody in your organization. So if you're an administrator, please take this to the folks who are your technical architects and leaders, because the fact is that we've all been hurt by poor quality code. We've all had our velocity diminished because some code was really challenging and tough to understand. So the mechanisms that we're going to be sharing today will help elevate the quality of the code that is in your Salesforce org. Not just now, but forever going forward. Okay, so what are we going to be talking about today? We'll give a little bit of an introduction to PMD. We'll talk about abstract syntax trees. We'll go over some basics of Java and Maven. A little bit of a recap over some asynchronous Apex mechanisms that we have. And we'll talk about some custom rules that we want to define for how Apex is to be written, and then how to enforce those rules within your project. So PMD is the Programming Mistakes Detector. This is an open source tool that has been really heavily used within the Salesforce ecosystem. And it's what we call a static code analysis tool. So it's a static code analysis tool. And what that means is it parses the text file that is your source code and finds structural issues with just the way that your code is written. This is not necessarily about how your application behaves once this code is running, but it's just structural issues with the way that it is written. So you could detect things like, hey, this is improperly capitalized. You might have a DML operation in a loop. You could have missing comments. Anything just about the way that the actual class file is written itself. And it's most commonly distributed within the Salesforce ecosystem as a Visual Studio Code plugin. So when you're in VS Code, you'll get these little yellow squiggly lines underneath your problematic code. And it'll say, hey, Apex unit test should have at least one system.assert statement, right? So you'll hover over it and you'll get the message that says, hey, here you have a problem. This is exactly what the problem is. So with all of these PMD rules, they all have what we call a priority. 5 is the lowest priority. It's kind of like a, hey, just FYI, here's something that is an opportunity to improve, where 1 is the highest priority. 1 is like, you need to fix this right away. And PMD comes with a collection of rules by default, but the thing is that the rules that PMD contains are not exhaustive of all of the quality signals that you should be enforcing in your organization. You're going to want to expand beyond the scope of the included default PMD rules if your organization already has a defined style guide. And if you don't already have one, I would definitely recommend that you create one. If there are certain issues that continue to pop up time and time and time again during code review, it's like, hey, we really need to make sure that we include the private access modifier. If that keeps coming up, you might want to consider writing a PMD rule for it. And then finally, if there have been issues that have not been caught by the out-of-the-box PMD rules that have caused, problems in production, then those are some things that you would want to consider writing your own custom PMD rules for. Okay, so now we're going to switch gears here. How does PMD actually work? It works using a structure called an abstract syntax tree. This is a very quick computer science lesson. We won't go too much into detail, but these are the inner workings of how PMD actually how PMD rules actually are executed on your source code. So an abstract syntax tree is just a syntactic representation of the structure of a program's source code text. And each node within the tree corresponds to some element within the source code. And by abstract, we mean it doesn't have all of the details, it's just the core structure. So you get this tree structure, and the nodes represent things like parameters, methods, variable assignments, inner classes, annotations, comments. So you have this tree that basically breaks down the overall structure of the Apex class that you're looking at. So what might that look like? So if you have a little snippet of Apex code over here, right here we've got this while statement, and we're going to return A. An abstract syntax tree representation of that might look something like this. So it takes the actual source code and translates it into a structure that defines the actual structure of the logic that you're trying to do with the source code that you have written. And this is how PMD actually operates. You define rules that parse this abstract syntax tree on your Apex class. And then based on the structure of the nodes that you find, you can say, hey, this is a violation of the way that we would like our Apex to be written at our organization. Okay, so what PMD is cool, but it's written in Java. So we're going to need to go off platform for a little bit to be able to understand some of these mechanisms before we can actually write our own rules. So Java is the world's most dominant object-oriented programming language over the last 25 years or so. It was created by Sun Microsystems in 1995. Fun fact, it was actually originally created for interactive cable TV box sets. So you'd be like interacting with your remote. That's what Java was originally created for, but it has since proliferated into basically every enterprise on the planet. And the Apex syntax that we write code in for Salesforce is based on Java. So a lot of these things that you're going to see shouldn't look terribly unfamiliar, but there are a little bit of language structural changes. So when you're writing Java programs, the .java file extension is the file extension for your source code. Then you'll run that source code through a Java compile command or Java C command, which will produce a file with the extension of .class. So this is the compiled version of your class that you just wrote, okay? And you can have multiple compiled files are bundled together in what we call a Java archive or jar file, and they can be executed like that. So jar file is kind of like a zip file. It's an archive. It's a file that contains multiple files. Okay, when you're writing Java though, you're probably not actually going to run the Java compile command directly. You're probably going to use a build tool like Maven. So Maven is an open source build tool created by Apache that simplifies the act of building, compiling, packaging, installing all of your Java-based source code. So, and there's a thing similar to the node package registry like NPM. There's a Maven package repository, so that way you can fetch your dependencies much easier when you're building Java projects. Just like each, if you're familiar with node development, you have a package.json that specifies these are the package dependencies that I need to fetch from the registry. There's a specific file called the project object model XML file. We call it pom.xml, which defines, the configuration for versioning, dependencies, and all of the build steps to build a project. And so the Maven repository stores packages that are available, such as like JUnit or PMD. So you can specify in your POM file, hey, I need this version of JUnit, this version of PMD. Build me a project that actually contains those things, and it'll pull it from the repository, and you'll be able to get a compiled archive that you can use in your project. The Maven package command is really where the magic happens. So this reads your pom.xml, pulls all of the dependencies that you need from the repository, and builds everything into a jar file for you. Okay, so that's enough about Java and Maven. We'll go back to Salesforce. So those are just kind of some foundational things that will help us as we understand these mechanisms that we're talking about. But we're just going to focus on asynchronous Apex for the scope of today's presentation. And we'll give a quick recap of some asynchronous processing mechanisms that we have within the Apex programming language. So the oldest and most classic way that we can, segregate some of our processing to a different transaction is using the @future annotation. So a lot of times you would need to create a separate transaction. Maybe you need to update user records. User records cannot be updated in the same transaction as, for example, account records. You'll get an error called mixed DML. So the @future annotation basically provides you a way to say, hey, here's a static method. And when I call this static method, it's going to get its own separate transaction, and it's going to be performed asynchronously whenever the platform has the resources to do so. This is the old way of doing it, though. There are some serious limitations with the use of the @future annotation. So the input types are limited to primitive values, right? So you can't pass in like a collection of users. You need to give in a collection of user IDs, for example. And furthermore, there's really no way for us to detect failure. So if something went wrong here, we don't really know. There's no good way for us to like send an email to the person who called that future method in their transaction to say, hey, we were actually unable to successfully update these users that you just tried to do. So future annotation is the old way to do it. It's worked well in the past, but there's a better way, and that's the queuable interface. So the queuable interface is just generally speaking a better, more recommended way to handle asynchronous transactions. It can accept more complicated data types in at its construction that can then be used. So you could pass in a whole list of fully populated users instead of just a list of IDs, for example. One thing that's really nice about queuables is they can be chained together as well. So you could have like, queuable A then calls queuable B, which then calls queuable C. So you can have this chain of asynchronous processing to be completed, which is very, very cool. And there's something that's pretty new in Salesforce for the queuable interface. It's called the Finalizer interface, and it allows us to register what we call a transaction finalizer. So a transaction finalizer means that, let's just say I had enqueued a queuable job, and I want to perform some code when that job is completed. So if it goes successfully or if it's unsuccessful, maybe I want to send an email, or maybe I want to log that something was successful. The transaction finalizer allows us to do that. So we can create an instance of a finalizer and attach it to our queuables execution using system.attachFinalizer. Okay. And then we check this context.getResult, and it gives us an enumeration called parent job result, which could be success or unhandled exception, and then we can choose how to move forward from there. So these are some of the things that have throughout time on the Salesforce platform developed as best practices for asynchronous Apex processing. And there's really no out-of-the-box PMD rules that say, hey, use of a future annotation should probably not be done. Maybe let's use the queuable interface instead. Or hey, when we're using a queuable, let's attach a finalizer to make sure that we can detect when something goes wrong during a queuable's invocation. So those are some of the rules that we're going to be talking about today. Okay. So we're going to go over a couple of rules. Number one is do not allow the use of @future annotation within a class, and provide the reader of the violation of that rule with instructions to say, hey, you should use the queuable interface instead. Okay. And then the second rule is we want to require the attachment of a finalizer within each queuable class. And we want to explain to the reader that, hey, the lack of a finalizer really provides no reporting capabilities should the queuable action fail. So these are two of the rules that we're going to go over today, and they're going to be written in Java. And then we're going to be able to do some really cool stuff with them, but I'll show you that in just a second. Let's switch over to a project. Okay, I've got Visual Studio Code up and running here, and I've already written these rules. So I'm not going to go through all of the steps of writing the rules from scratch. Rather, I'm just going to show them to you. So first, I'm on my main branch. Let's check out another branch called Apex Hours. Okay, so now I'm on Apex Hours branch, and let's take a look in the source. Right here, we've got the Java folder, and you say Java com, my company. This is the de facto folder structure for a Java project. And the first rule that we're going to take a look at is avoid future. Okay, so by avoiding future, what we mean is, this is the very, very simple rule. We're going to visit an annotation node in the abstract syntax tree. And if that node's name, which is returned when we call .getImage, equals future, then we're going to add a violation to that node. It's as simple as that. So we visit a node of the abstract syntax tree. We determine what, get the value at that node, check its children, check any properties of the type of node that we're visiting, and then we can determine if we need to add a violation or not. So once we've defined this particular class, we can then create a rule set file, or a rule file, excuse me, that really kind of ties it together. So for folks who are familiar with PMD, you have a rule set file that specifies these are the rules that you want. This is how we actually define those individual rules. So the rule name here is called avoid future. You associate what is the language that this rule is applicable to, and then you tie it to the class that has the definition of the rule. So my company, PMD, avoid future. That's the class that we're talking about here. And you give it a message. So the usage of the @future annotation should be limited. Please consider implementing the queuable interface instead. Okay, so this is what it means when we specify writing a rule, a custom PMD rule in Java that we can then use and bring that up within our own projects. So before I dive into the require finalizer rule, let's take a look at what it means to build this stuff, okay? So all that we need to do is we need to have a pom.xml. This specifies, hey, I'm going to use Java 11. I'm going to create a jar that's called, PMD rules version 1.00. I'm going to pull down PMD version 6.55 and some of these other things that I need from the Maven repository. And then I'm going to compile it. That's going to include all of the class files and any XML that I include in the category folder. That's basically what this POM means. Now, don't get too bogged down in this. All of this stuff that I'm going to share with you, including the source code for the avoid future rule, the require finalizer rule, this pom.xml, all of this is available on my blog. So you don't need to get too in the weeds or take any screenshots of this code. You can just get it in the blog post itself. But what we'll also see here in the project's repository, in the project's directory, is we have this folder called target. Okay, target is created when we run that Maven package command. So what I'm going to do is I'm going to delete this, and I'm going to say Maven package. So now Maven is pulling all of the stuff from the repository and following all of the directions that I defined in the POM to rebuild the target, okay? Now we have our compiled classes, and we have a jar that contains everything that we need to run. So let me just get rid of this. These got updated because just redid it. So let me get rid of that and go back to the stuff that we had previously. All of these are still there. We still have the classes. We still have the jar. But now let's figure out, like, okay, we've got this rule. We've got this jar. How can I actually make this work in Visual Studio Code? And the steps are pretty easy. So one thing that we do is we have this Apex, asynchronous Apex XML. What we've done is I created this file called all rules. And this is kind of like a global rule set file that contains all of the standard definitions of rules, plus any custom rules that we have, including that async Apex rule. So what I'm going to do is I'm going to open up the user settings in the UI for Visual Studio Code, and I'll go to the extensions, and I'll go to Apex PMD extension, which you guys should be already using. If you're not, you can just install it from extensions, search the marketplace for Apex PMD. This is the one by Charlie Jonas, okay? So let's go back here. What we need to do is we need to find this all rules XML file. What I'm going to do is I'm going to copy the path to that. And let's go back to here. I'm going to set the rule set to the path that we have. Okay, cool. So now we've got compiled rules. We've referenced them within the Visual Studio Code Apex PMD plugin. Now let's go ahead and let's see them live in action. So what I'm going to do here is let's close all of these windows that I have open. Let's create a class called demo. You know, let's create the folder. Make sure that this is okay. Cool. Class demo. Interesting. Main default. Oops. Classes. Class demo. I'm not sure why it's not showing up in the list of applicable directories. Let me just put it here and then I'll move it. Okay, cool. So that's now in Force App. So I've got this class called demo, and let's go ahead and let's populate it. And I'll save it now. Inherited class demo. We've got, hey, we're going to deactivate some users. We call this private static method. And here we see a yellow squiggly. It says the usage of the app future annotation should be limited. Please consider implementing the queuable interface instead. Okay. So this is pretty cool. We've been able to define a custom rule using Java. We've been able to define our project's definition that says, hey, I'm going to compile this rule. And when I do that, I'm going to fetch all of these things from the Maven repository. I'm going to create something called PMD rules.jar. It's going to contain my asynchronous Apex XML definition. And then when we bring that PMD rules.jar, we can use that and reference that within the all rules.xml. There's one thing that we also need to do. I've already done this, so my apologies. I kind of glossed over this. You need to, so we already defined the rule set. We need to add an additional class path to the jar that we compiled. So there's two steps: add the class path to the jar and then add the additional rule set. Then you can get your custom rules to show those violations locally when your developers are writing code. Okay. So that is pretty neat. Let me close this. Let's take a look back here. But we have a violation, right? We'd like to be able to change this violation. So let me see here. What if I were to commit this? Apex hours demonstration. Let's stage these changes and we'll commit them. Let's just say I'm a developer and I see this and I say, whatever, it doesn't matter. Okay. There's no real enforcement mechanism of this rule. It's a custom rule, but we haven't enforced it. So let me switch back over here. These are the steps to be able to get those rules to display in your local, right? So use PMD 6.55, add the PMD rules jar to the additional class paths, and then set the all rules XML. Okay, cool. How are we going to enforce this though? This is where it really gets interesting. Okay, we're going to let the robot be the bad guy here. One thing that we've done is we've created a GitHub action, or I've created a GitHub action called SFDX scan pull request. So let's go ahead and let's clear this out. Git push origin Apex hours. Oops, Apex hours. Okay, so now I created a new branch in the project's repository called Apex hours. I'm going to get out of this presentation mode and I'm going to go in here. This is the repository within GitHub, and it says, hey, the Apex hours branch had a recent push. Let's compare and let's create a pull request. I'm going to create a pull request on this one. Now, what we have going on in the background is a GitHub action. So you'll see here, Salesforce Code Analyzer. It's going to analyze the pull request. What does that mean? That means that if you take a look at the actual action itself, we'll click into details. You'll see it's doing a few things. This action is going to check out what we have. It's going to install the Salesforce command line interface in the scanner. And then it says, run SFDX scanner and report the findings as comments. So this is going to take maybe about a minute or two to do the installation. So while that's installing, I'm going to go back over here and show you how you configure these GitHub actions. You have a folder called .github workflows, and there's a YAML file that specifies what are we going to do. So when a pull request is opened, reopened, or synchronized means a new commit has been added. Then the first thing that we're going to do is we're going to check out the repository. We're going to install the SFDX CLI in the scanner. And then we're going to run this GitHub action that I authored called SFDX scan pull request. And we've got some input flags. So we're going to report the findings as comments. We've got a severity threshold of 2. And we've got some strictly enforced rules. And here is where we get interesting with the custom PMD rules. So here it says, hey, I've got some custom Apex rules that are at the path target PMD rules 1.0.0 jar. Okay, so here this allows us to register our custom rules within the scope of the action that's running. So here we'll see, it took 51 seconds to install the scanner. It says run SFDX scanner and report findings as comments. So here you can see some of the things that it's actually doing. Scanner rule add the path that we defined and then the language. Okay, scanner run the classes and the files that are part of the pull request. Filtering findings to just lines that are part of the pull request, writing comments to GitHub using the REST API. And then that's where it ends, right? It says everything is successful. Let's take a look at our pull request right here, Apex Hours demonstration. We'll see that we have a robotically generated comment that everybody can see immediately when they're reviewing the code that has been proposed as a change. And we'll see, hey, this is a violation caused by PMD. The category is asynchronous Apex. The rule that was violated is the avoid future rule. The severity or priority is 3. We're going to treat this one as a warning, though. And the message is the message that we had defined. So with this, you can automatically surface these findings, not only within Visual Studio Code, right here within the yellow squigglies, but also for anybody who's performing a code review on the proposed code changes that you have defined. Now, okay, this is great that we get the bot to generate the comment that contains the findings. This is very cool stuff. However, it still says that the action was successful. So if I take a look at the action, it says, oh, okay, we got a green checkbox. Apex Hours demonstration was successful. Let's go back in here and let's make another commit. Right here, let's take this severity threshold. Severity threshold is one of the 2 mechanisms that we have for enforcement. So we got severity threshold, which specifies that if something is found with severity of 2 or 1, then we're going to fail it. So if we drop this down to 4, for example, then this is going to be more strictly enforcing rules. So the only violation that we can have that's going to be treated as a warning will be 5. Anything more serious than a 5 is just going to be treated as an error. Okay. And furthermore, let's go back right here and let's take a look at this pull request. And all right, so I took a look and I said, okay, maybe I should avoid future annotation. Let's go ahead and we'll mark that as resolved. So I'm going to come back here and let's update this class. Instead of using the future annotation, let's update this so that way it uses the queuable interface. Okay, I'll save it. And so it's using queuable. We get a set of user IDs and we say update the users. We're still calling the same static method here. We're just updating these users and setting them to not active. But you'll see that we have another violation. It is best practice to call system.attachFinalizer within the execute method of a class which implements the Qubel interface. This will enable the handling of unsuccessful asynchronous processing. So this is another violation, okay? And that's within the require finalizer rule. This one is more complex. I chose to do the avoid future as like kind of a simple, trivial, this is the syntax that you're working with kind of example. This one is a little bit more complex. I'm not going to go into too much depth here, but it says, hey, we're going to visit the entire class. We're going to scan the top level class for violation and also any inner classes that it has. So top level class, find descendants of type user class. So this is, we're traversing the nodes within the Apex abstract syntax tree. What does it mean to scan the class for violation? If the class does not implement the Qubel interface, then we don't care. We'll just return. But if it does, then what we'll do is we'll find all methods within that class. And if that method is the execute method of the Qubel interface, and that method does not call system.attachFinalizer, then we're going to add a violation. Okay. So you can check, for example, within a given class, you can say, hey, what are the interfaces that this class implements? Or when you have a method, say, hey, what's the name of this method? Or what are the parameters that we're passing into this method? So all of this stuff is available to you when you're writing custom PMD rules because it has structural representation within the abstract syntax tree. And we can get really, really specific with our rules. Okay. So here, let's go ahead and let's make another commit. Update to Qubel. So let's stage this, commit it, git push origin apex hours. Now, we still have a violation. And if we take a look within our asynchronous apex rule violation definition, it says it's priority 3. Okay. However, the threshold that we have is 4. So anything above or equal, anything that's 4 or 3 or 2 or 1 should cause failure. And we have 2 particular ways that we enforce these rules. One of them is severity threshold, and the other one is strictly enforced rules. So the severity threshold throws an error when violations of a specific severity or more severe are actually detected. So it could be 2, it could be 4, it could be whatever you want. 5 is like the lowest priority threshold. So if you do, my probably recommendation would be use this with whatever makes sense for your team. I personally would put this at a 4 or a 5 just to be as strictly enforcing code quality standards as we can be. But let's just say, you have this at 2, there might be something that is a 3, but you still want to enforce it. Or maybe it's a 5 and you still want to enforce it. That's where the strictly enforced rules comes in. So a JSON string that defines the rules that will be strictly enforced regardless of their priority. Okay. So you can say, hey, when the engine is PMD, the performance avoid debug statements rule is going to be strictly enforced regardless of what its priority is or what our threshold is. Okay. So let's go back over and take a look at this. Let's refresh this 1 second. Oh, so the action has already ran again. So if we take a look at the actions, it ran and it was unsuccessful. It took 1 minute and 10 seconds. And you'll see here that it was unsuccessful because 1 or more errors have been identified within the structure of your code that will need to be resolved before continuing. So if we go back to the pull request, you get this little red X saying, oh, no, it failed. You can't move forward. And the reason why you can't move forward is because we have an error that says asynchronous apex. We're going to require the finalizer. It's best practice to call system.attachFinalizer within the execute method of a class which implements the Qubel interface. So we have a lot of really cool stuff here. Very, very powerful stuff. We can define our own custom rules, and they can be as granular or specific as we want, right? We can compile those rules and run them locally within Visual Studio Code to give our developers a heads up that something is wrong. But if they choose to move forward and still create a pull request anyway, knowing or maybe ignoring the violations that we have these enforcement mechanisms to surface those findings to whomever is performing the code review, and then programmatically fail the execution of the action if a serious violation is detected. With the combination of all these mechanisms, you guys can really, really programmatically codify what it means to write good quality Apex at your organization. And not just codify that, but programmatically enforce that. Let the robot prevent somebody from breaking those rules in the first place. By the time that something, so let's carry on with this. I'm the developer. I said, oh, you know what? Shoot, I need to require the finalizer. Okay, so I'm going to resolve this conversation. Okay, checks have failed. So let's go back and let's finish this once and for all. So now I'm going to say, okay, this demo class implements both Queuable and Finalizer. And I'm going to call system attached finalizer. And when the finalizer executes, if there was an unhandled exception, then I'm going to send a failure email. Okay, so let's save this. We'll go here, add finalizer, commit, push it up to our remote branch. Now, as we come in here, we'll refresh the screen, and it's kicking off the job again. It's checking out the repository. It says, okay, we've got the Apex hours branch. We're going to try to merge that into main. Here's the pull request that is of interest. It's going to take a minute or two. We'll just watch this thing live. It's going to take a minute or so to install the SFDX scanner and the SFDX CLI and the scanner command, scanner plugin. This will take a moment to do so, but what'll happen after that is it's going to run the GitHub action that we defined. It'll take a look and scan the files that are part of the pull request. It will run those custom rules and the standard rules that we've defined against the contents of that pull request. It'll filter it down to just the lines that are part of the pull request. So if you have some huge file, you're not on the hook for all of the findings of the file, just the lines that you've changed. And it will then take those findings, report them as comments in line. And if there are no errors, then everything will be successful and you'll be able to move forward with your pull request. So right here, looks like everything was successful. Here's my pull request, Apex hours demonstration. There we go. No new findings. Everything has passed. And now you can move this forward up the chain and ask a more senior engineer to take a code review. So let's go back into the slideshow. All right, what have we learned today? All right, PMD is way more than just yellow squiggly lines in Visual Studio Code. PMD is a really, really cool engine that you can use if you take a little bit of time to invest, if you invest a little bit of time to figure out how can I interact with this abstract syntax tree to define structural rules for the way that Apex is to be written in my organization. Abstract syntax tree are the mechanisms for how static code analysis tools like PMD actually operate and execute. Java and Maven, we learned a little bit of the foundations for writing, compiling, and running our custom rules in Java. We kind of went over some of the standards for asynchronous Apex, going over the app future annotation, the queuable interface, and then the transaction finalizer interface. We defined a couple of custom rules that help us to ensure that we're writing our asynchronous Apex properly. And then we also showed how we could use the SFDX scan pull request action to automate a portion of your code review and enforce your code quality standards. So there's been a lot of content, very deep and technical. So I've got some resources here for you folks. Part 1 and 2 of a blog post on my blog. Part 1 it talks about what does it take to actually write and compile these PMD rules. Part 2 talks about how do we register them and execute them within the SFDX scan pull request GitHub action. Here's a link to the actual SFDX scan pull request action itself. And then finally, I include a link to the Java doc for PMD version 6.55, which is the most recent version to be included within the SFDX scanner CLI plugin. So that's why we're using 6.55 instead of 7.0.0. So all of these are going to be really great references for you. Again, you don't need to like go back and pause and take a look at the screen and figure out what the source code was. It's all available for you right here. So let me take a look at PMD part 1. You know, all of the stuff that we just went over. What is PMD? It's a Visual Studio Code plugin is how you're most likely going to see it. Here's an abstract syntax tree. Here's a project repository breakdown. Here's the definition of the avoid future rule. So all of this stuff is available for you. You can go and you can read it at your leisure. You can also take a look at the scan pull request action itself. This has documentation, so it includes like, hey, here's what a comment looks like when it gets actually executed in the scan. It's got documentation for all of the types of input that you can pass. All right, so here's how we compile a master rule set. Here's how we register custom PMD rules. Here's the severity threshold and the strictly enforcer. So all of this stuff is available for you to read at your leisure, and you can go over it and learn more about it and share it with your team and share it with your technical leaders in your organization. So with that, that is the scope of my presentation today. Thank you, Amit, for having me. This is always a pleasure. I'm super excited about this stuff. This is really, really powerful. With this, we can elevate and enforce higher code quality standards for the way that Apex is to be delivered at your organization. And you can get more out of your senior engineer's time by having the robot do the enforcement of these standards for you. So by the time that something actually comes up to a senior engineer and is ready for code review, odds are it's probably in really good shape. So thank you again, Amit. This has been awesome. I'd like to take any questions that we have. I know that we're kind of a little bit over time, but if we have any questions, please send them my way.
Yep. So one question quickly. There is a question from Shiva. Also, can we stop the people from making the push itself? We can set the git hook. This will be ensure that if we have a big org, committer does not need to wait for queue to clean up to know would this status. So in short, he want to check it out. Can we stop the people to push itself?
Yes, that's actually a great call. So the Git has a thing called the pre-commit hook. So let me just go right here. I'm going to open up the settings. Every single Git project that you have has a hidden folder called .git, okay? And it's hidden by default. So let's take a look at text editor, files. In Visual Studio Code, they don't show it to you. So let's just make it expose .git. Let's just say 1, 2, 3. So now you can see the .git folder, and it's got this folder called hooks. Hooks has a lot of things, and one of them is called precommit.sample. So basically, if you just remove the .sample from this, just call this precommit, then this will be a shell script that will be executed locally before you even create the pull request that could be used to prevent things from to run the scan and prevent violations from being even committed locally in the first place. So that's a really good call out and a great mechanism. I chose not to do that on this one because I know that we had a little bit of limited time, but yeah, I definitely would recommend emulating basically what the scanner action does locally in a pre-commit hook. So that way you can shift even further left the identification of warnings and errors and issues with your Apex code.
So any other question into the chat window? So Shiva,
Yes.
Yeah, go ahead.
Go ahead. I was just going to say, it looks like somebody said that You can skip the git pre-commit hook by using the --no-verify command. So that is one of the main reasons why we want to have that GitHub action to do the backend enforcement for us. Somebody could choose to just ignore the blockers that they face locally. So the backend enforcement is the ultimate fail-safe.